Let's look at section 1.6, scientific notation. Once again, scientific notation is a repeat for us from our math minutes earlier this year, and you've also looked at it in previous school years, so this should be review. Now remember that scientific notation is when a number is written as the product of a factor and an integer power of 10 and remember that the factor must be greater than or equal to 1 and less than 10. Now, in simple terms, that means that the number to the left of your decimal point has to be, there should be only one number to the left of your decimal point, I should say, okay? So it's going to be greater than or equal to 1. It's going to be less than 10. So you need to have one number to the left of the decimal point. So an example would be 425 million is going to equal 4.25 times 10 to the 8th, because we're going to take our decimal and we're going to move it over 1, 2, 3, 4, 5, 6, 7, 8 until we only have one number that is greater than 1 and less than 10 to the left of the decimal point. So 4.25 times 10 to the 8th. Let's look at some rules to express a number in scientific notation. If the number is greater than or equal to 1, the power of 10 is positive. If the number is between 0 and 1, the power of 10 is negative. With the powers of 10, when you multiply a factor by a positive power of 10, it moves the decimal point to the right. And when you multiply a factor by a negative power of 10, it moves the decimal point to the left. Now, this is going to be a lot easier, again, once we take a look at the examples, because you have done this before. So let's take a look at some examples. We have 2,375,000. Well, the first thing I notice is that this number is greater than 1, right? It's much greater than 1. It's 2,375,000. So I know that my power of 10, or my exponent, is going to be positive. So if I take my number out here, I know that I have to move my decimal point to the left 1, 2, 3, 4, 5, 6 times in order to get a number, just one number to the left of my decimal point. So I get 2.375 times 10 to the 6th power, because my number that I started with was greater than 1. Now, this number, 0.000254, is a number between 0 and 1. So it's smaller than 1, but it's greater than 0. If it is between 0 and 1, then my power of 10, or my exponent, is going to be negative. So let's take a look at it. I'm going to move my decimal point over 1, 2, 3, 4 places until I have one number to the left of the decimal point. So 2.54 times 10 to the negative 4th, because this number was less than 1. Let's look at example 2. This time, we're going from scientific to standard. So up here, we were going from standard to scientific. And down here, we'll go from scientific to standard. .25 times 10 to the second. So I'm going to just write my number out here, 2.25 times 10 to the second. Now my rule says that when I multiply a factor by a positive power of 10, so my power of 10, my positive power of 10 is 2, my decimal point's going to move to the right. So I'm going to move over 2 places, and so my answer is going to be 225. Looking at the next part of the example, I have 4.86 times 10 to the negative third. Now this time I'm multiplying by a negative power of 10, so my decimal point's going to move to the left. So I move 1, 2, 3. So my answer will be 0.00486. I want you to take a few minutes, pause the video, and work the practice problems at the bottom of the page. Notice that numbers 1, 2, and 3 are going from standard to scientific, and number 4 and 5 are going from scientific to standard. Pay attention to what you're doing. Pay attention to your rules. Go back over your notes before you work your practice problems and try to do your very best on those. When you're finished, come back and we will complete the lesson. Okay, now that you are finished, I want you to make sure that you've done your best on the practice problems. Bring those problems with you tomorrow to class. We'll review over the notes, make sure that you understood the concepts, and then we'll move on to the next lesson.